At passive transport. Passive transport, we said, is not going to require any energy. You're moving down the concentration gradient, so from an area of high concentration to low, and it works until it reaches an equilibrium. That's not new, right? We've heard that before. And our forms were diffusion, which is just what happens when molecules move from high to low by bouncing off of each other naturally. Diffusion of water is called osmosis. And then facilitated diffusion is what happens when it has to use a carrier protein. So it's what happens when it has to use a carrier protein. Then you guys did a lab where you had to predict which way things were going to move in and out of the membrane, right? And you did that based on concentrations. Now, we already said that things that are charged or very big can't freely pass the membrane. Sodium chloride, salt, they're charged. Those are charged particles. They can't just cross the membrane. So what has to move to try and balance concentrations instead will be the water. So we have to determine the concentration of water inside and outside of our cell. So if we look at this, we have a cell and a beaker. Inside the cell is 5% sodium chloride. Outside of the cell is 5% sodium chloride. Now, 5% means 5% of that solution is sodium chloride. It's the solute. The solvent is our universal solvent, water. If 5% is sodium chloride, how much is water? 95% water. And we have to figure it out because water is the thing that's going to do the moving. In my cell, it's 5% sodium chloride, so 5% solute. How much solvent is it? 95%, because it always adds up to 100, right? Now we have to look at the numbers. We look and see if one is higher than another. Water is what moves. If it's 95% water on the outside and 95% water on the inside, what way does water move across the membrane? If it's going down its gradient. You're like, wait a minute, but it's already at equilibrium, right? Does it have to move at all? So equal amounts are going to go in and out just because things are naturally always moving. We call that no net movement across the membrane. And we label this system with one of our words from our bell work today. We call this system isotonic. Tonicity is the word we refer to when we talk about the concentration of salt. Iso is just like your isosceles triangle. What makes an isosceles triangle special? Sides are equal, right? Iso means same. So here, the same concentration of solute is isotonic. Make sense? No net movement because concentration inside, outside, they're the same. Next scenario, we have a beaker and a cell. It's 5% solute on the outside of the cell, and it's 10% solute on the inside. How much solvent is there on the inside and outside? It's 10%. How much solvent is in the cell? 90% water. And it's 5% sodium chloride on the outside, making it how much water? Will water move in or out based on that? Remember, it moves down the concentration gradient. It goes from where it's highly concentrated to where it's low. Where is the number higher? Here it's going to go into the cell, causing the cell to swell if it's a plant or burst if it's an animal, because it doesn't have a cell wall. So that extra pressure of water rushing in, it's like a water balloon when you overfill it, right? So that happens here. And we say, based on solute concentration, 5%, we say the outside of the cell is hypotonic. Hypo meaning less, so it has a lower concentration. Hi.
Box tissues, please.
Yes.
Thank you.
So we do it based on the solute concentration. We label hyper, hypo, iso. So here, the outside is hypotonic. So the cell has been placed in a hypotonic environment. And when water rushes in, it swells or it bursts. The resulting pressure that causes swelling or bursting is turgor pressure, which is one of your words from your bell work on Thursday. Turgor pressure. And the act of water rushing in or out is called plasmolysis. So, because it affects the plasma, right? Cytoplasm. So we call it plasmolysis. Plasmolysis? The pressure that results from water rushing into the cell. Our cell is 5% sodium chloride. What is the concentration of water inside the cell? And outside of the cell? Taking a look at what can cross the membrane, remember water is what can cross the membrane, 90 to 95, we go from high to low. Your hypothesis was what would happen in this scenario? And water does in fact rush out. This would cause cell shrinking, so it would cause the cell to shrivel up. And in this case, we say 10% is hypertonic, meaning higher. Hyper is higher. So it is a higher concentration than inside the cell. Those are all characteristics of active transport. Requires ATP, moving up the gradient. It's for large polar charged things. The forms you should be familiar with are the sodium-potassium pump and endocytosis and exocytosis.